Guys, you're welcome back. Today we'll be dealing with binomial theorem, will be our main topic. And binomial theorem, it's just a way of expanding brackets. Let's say you have a plus x to the sixth power. How do you expand it to come about to know the coefficients of each? So there are two methods. The first is using the Pascal's triangle. The second is using combinations. So we'll begin by using the Pascal's triangle. Okay, the Pascal's triangle is very easy and I consider it a game. So we'll draw it together, we'll draw the pyramid so that it sticks. We always begin with 1, let's say 1, we have 1 here, 1 here. Now you write 1 at the extreme, this plus this gives 2, and you write 1 at this end. You start 1 again, this plus this gives 3, this plus this gives 3, and it ends in 1. We write 1 again. 1 plus 3 gives 4. 3 plus 3, 6. 3 plus 1, 4. And we write 1 at the end. 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And ends in 1. It continues 1 plus 5. We start with 1 here. 1 plus 5, 6. 5 plus 10, 15, 10 plus 10, 20, 15, 6, and 1. So you can just continue as, it's just very easy. You just see this plus this gives this. Okay, so that was the Pascal's triangle. We'll come back to it. So let's come to combinations, the second. Combination has this formula, n combination r equals to n factorial all over r factorial in bracket n minus r factorial. I know this looks a little bit scary, but there's nothing to it. Let's first of all understand the principle of factorial or factorization. If we say 5 factorial, what does it mean? 5 times 4 times 3 times 2 times 1. So that's the meaning of 5 factorial. So 3 factorial will be 3 times 2 times 1. 3 times 2, 6 times 1, 6. It will be 6. So that's the principle of factorization. Okay, so we have to memorize this formula. N combination R is this. So let's take an example 2 combination 0. What does it give us? We use our formula. We have 2 factorial divided by R, which is 0. 0 factorial N is our 2. 2 minus 0 all factorial. If we simplify it, it gives us 2 factorial divided by 0 factorial is considered to be 1. 2 minus 0 is 2. Divided by 2 factorial. So 2 factorial divided by 2 factorial will give us 1. So our answer here, 2 combination 0 will give us 1. Now let's take 2 combination 1. 2 combination 1 will give us 2 factorial all over 1 factorial in bracket 2 minus 1 factorial, and that can be simplified as 2 factorial all over 1 factorial is 1, 2 minus 1 is 1 factorial, so that will be 1 times 1, which is 1, 2 factorial is 2 times 1, so 2 times 1 divided by 1, so that's 2. So our answer here will be 2. Combination 0 to be 1, 2 combination 1 gives us 2. So let's take 2 combination 2 and see. 2 combination 2. Our formula says 2 factorial divided by 2 factorial into 2 minus 2 all factorial. So what we have here is 2 factorial divided by 2 factorial. 2 minus 2 is 0, so that gives 0 factorial. I know 0 factorial is considered as 1. So 2 factorial into 2 factorial, that gives us 1. Let me simplify this. 2 factorial into 2 factorial, that means 2 times 1 into 2 times 1, which is 2 divided by 2, which is 1. So if I write it down clearly, 2 combination zeros answer is 1. 2 combination 1 gives us 2. 2 combination 2, sorry my bad. 2 combination 2 gives us 1. So now if we take a look at the Pascal's triangle, you see we have 1, 2, 1. And if we come to the triangle, we have 1, 2, 1. Same values. So these are just values of the coefficients. So you can either go by the Pascal's triangle or you go by the combinations. So now we'll go now into what the coefficients are all about. Okay, so from what we have seen, we can either use the Pascal's triangle or the combination methods to get the coefficients. So now let's take an example so that we start. And before we go, let's say this is row 1, because it has just 1, and then this is row 2, he has to row 3, and comes down, where 4 begins to row 4. Okay, let's take an example. We have x plus 5 all raised to the power 4. We are given this. So it will be impossible to write x plus 5 times x plus 5 times x plus 5 times x plus 5. So let's try to get the coefficients. When we see the power 4, it means it has to do with row 4. Row 4 is where we have 4. So the coefficients we have here are 1, 4, 6, 4, 1. So here we write the coefficients 1, 4, 6, 4, and 1. Now we'll take the power x. For x, its power goes in descending order. So here we have x to the maximum power, which will be 4. Here we'll have x, one step down, 3, x squared, x, and x to the 0. And for this one, which is 5, it will increase. The powers will go in ascending order. So we have 5 to the 0 here, 5, 1, 5 squared, 5 cubed, 5 to the 4th. And since the sign here is positive, everything is positive, we write plus in front of every factor. So now we can open this. 5 to the 0 is 1. So 1 times x to the 4 times x to the 4 plus 5 times 1. 5 raised to the power 1 is 5. 5 times 4, 20. So we have 20 x cubed plus 5 squared, that's 25. 150 x squared plus 5 cubed. 5 times 5 times 5, that will be 125 times 4. That will be 500 x raised to the power 1, that's 6, plus 5 to the 4th. 5 times 5 times 5 times 5, that's 625. Now x is raised to the power 0, so x is 1. So this is it. So using Pascal's triangle, we've expanded this, and this is what it has given us: x squared plus 20x cubed plus 150x squared plus 500x plus 625. So we'll do this same question using combinations and get the result. Okay, so this is it. Our question was x plus 5 raised to the 4. So now, since it is 4, this will be our value n. So our n will be 4. So it will be, see, remember our formula: n combination r equals to n factorial divided by r factorial n minus r all factorial. So our n will begin with 4. So the first value we'll get is 4 combination 0. Always begin with 0. 4 combination 0. Let's see what value gives us. 4 factorial divided by 0 factorial, which is 1, as I said earlier, 4 minus 0 all factorial. So that gives 4 factorial 1 times 4 minus 0 is 4 all over 4 factorial. So that will give us 1. So our first value is 1. Second value, 4 combination 1. Following our formula, we have 4 factorial divided by r, which is 1. 1 factorial n minus r, 4 minus 1, 4 minus 1 all factorial. So that will leave us with 4 factorial. 1 factorial is 1, 4 minus 1, 3 factorial, divided by 3 factorial. So now to simplify this, you can simply write 4 times 3 times 2 times 1 divided by 3 factorial, 3 times 2 times 1. So we'll see 3 times 2 times 1 equals 3, 2, 1. So we'll be left with 4. So the value for 4 combination 1 is 4. Let's get 4 combination 2. 4 factorial divided by 2 factorial, 4 minus 2, 4 minus 2 all factorial. That will give us 4 factorial divided by 2 factorial and 4 minus 2, 2 factorial. Simplifying this, we have 4 times 3 times 2 times 1 divided by 2 times 1, that's for 2 factorial, 2 factorial, so we have times 2 times 1. So you see, 2 times 1 will give up here. So we have 4 times 3 divided by 2 times 1. 4 times 3 is 12. 2 times 1, 2. So 12 divided by 2, which is 6. So 4 combination 2 gives us 6. Now let's go in here. Okay, so we'll go with 4 combination 3. Using our formula 4 combination 3, it's 4 factorial divided by 3 factorial into 4 minus 3 all factorial. So simplifying this, this will give us 4 factorial divided by 3 factorial, 4 minus 3, 1 factorial. So this can be simplified as 4 factorial into 3 factorial, which is 4 times 3 times 2 times 1 divided by 3 factorial, 3 times 2 times 1. So 3, 3, 2, 2, 1. So we'll be left with 4. So 4 combination 3 gives us 4 as value. And now the last is 4 combination 4. And keep in mind, when we're using this formula, R, the last value for R is always N. 4. When it's the same, then that's when we get the last value. So 4 combination 4 will give us 4 factorial divided by 4 factorial all on 4 minus 4 all factorial. So simplifying this, we have 4 factorial divided by 4 factorial. 4 minus 4, that's 1 factorial. And we know 1 factorial is 1. So it gives us 4 factorial all over 4 factorial. So that gives 1. So if we look back, we've got our values. 4 combination 0 is 1. 4 combination 1 is 4. 4 combination 2, 6. 4 combination 3, 4. 4 combination 4, 1. So that gives us as coefficients 1, 4, 6, 4, 1. And looking at our Pascal's triangle, that's what we have. That's what we use for the first 1, 4, 6, 4, 1. So with this now we can go ahead and open up same way as we did when we're doing the Pascal's triangle. So thank you very much for watching. In case you have any questions or misunderstanding, just write to us on the comment section and we'll get back to you immediately. Okay. Stay safe.